Augmented reality, also known as AR, is proving to be a promising technology. But can AR make it safer to navigate large ships? Or will the AR information actually be useful for the navigators? Well, let's find out. We will show you a range of examples of how we believe AR can be used on ships in the future. This is the result of several years of design research, including field studies, prototyping, and testing. We have recreated several scenarios in virtual reality to explore and demonstrate how AR could be used by navigators. Let's take a look at an accident scenario that happened in 2012. The cargo ship Vega Sagittarius departed from the port of Nuuk on the west coast of Greenland. Icebergs appeared ahead, so the vessel had to change its course. The navigators lost awareness of their surroundings, and as a result, the vessel ran aground on an underwater rock. Would this have happened if the navigators had AR headsets? Imagine you enter the bridge of the Vega Sagittarius. As you enter the workplace, an AR panel appears and adapts to your position on the bridge. In the AR panel, you see the most important information you need. As a result, you don't have to shift your attention between the environment outside and the screens inside. You approach some icebergs. The system identifies the objects outside and provides relevant status information. Small symbols above the horizon indicate your current course and heading, providing subtle feedback when the ship turns. As you approach shallow water, no-go zones are indicated on the ocean surface. Such overlays make it easier to understand how map-based information connects to the real world. Finally, the system informs you that you are approaching an underwater rock. In collaboration with Chalmers University of Technology, we have tested these AR concepts with several navigators. More trials are necessary, but the results so far indicate that these features could help prevent such accidents. Let's look at other examples of how AR can be used on the bridge. In this scenario, you enter the bridge of a small cruise ship approaching a large field of ice in Antarctica. On a large virtual AR screen, an ice forecast is presented to inform you about the conditions ahead. You can draw points on the ocean surface to discuss with your colleagues which route to take through the ice. The points are presented both outside and on the map. A grid and the radar image is overlaid on top of the ocean, helping you identify where you are in relation to large amounts of ice. As it becomes darker, you turn on searchlights, which you control simply by pointing where you want the light to go. To look at the conditions further away, you can use a night vision zoom camera and see the video feed next to the captured area. In the last scenario, you are on an icebreaker that is about to rescue a vessel stuck in ice before escorting two vessels in a convoy. When you look at the ship you are approaching, information about distance and your closest point of approach is presented above the ship. You find the same information in the vessel list in the AR panel. There is another vessel behind you, waiting for the convoy to begin. A vector line on the ocean surface indicates where you will be in 2, 4, and 6 minutes if you keep your current speed and heading. Walking to the aft bridge, you can see the ships are lined up behind you. The Icebreaker Assistance app indicates the relative speed and distance between each of the three vessels. Back at the workstation, the Icebreaker Assistance app is also a part of the AR panel. This makes it easy to monitor the speed and distances between all the vessels. We use the examples you have seen to create components and rules for how AR applications on ships should work. The next step is to test these concepts on ships and see if they work in real-world conditions. Finally, the result will be taken further in the OpenBridge project, which is an open design system for maritime workplaces. You can learn more on our Medium page or watch one of our other videos.